Chemical equilibrium. Now we'll be discussing significance of equilibrium constant Kc. The equilibrium constant is a constant for any given chemical reaction at equilibrium at a definite temperature. The value of equilibrium constant Kc is different for different reactions at equilibrium. It is also different for the same reaction carried out at different temperatures. The change in either pressure or concentration at equilibrium may change the state of equilibrium, but it cannot change the equilibrium constant, which depends only on temperature. The value of Kc indicates the extent to which a chemical reaction can occur. If larger is the value of Kc for a particular reaction, higher will be the concentration of the product formed. On the other hand, a small value of Kc indicates that lower concentration of the product at equilibrium will be low. For example, for the reaction PCl3 gas reacts with Cl2 gas forms PCl5 gas. For this reaction, value of Kc is 1.9 at temperature 293 Kelvin. Here low value indicates that at equilibrium the concentration of PCl5 will be low. Similarly, for another reaction, nitrogen gas reacts with hydrogen gas and forms product ammonia gas. The value of Kc for this reaction is 3.6 into 10 raised to power 8 at temperature 293 Kelvin. Here the large value of Kc indicates that a major portion of nitrogen and hydrogen will be combined to form ammonia gas. Now the relation between rate constants of forward and reverse reactions at equilibrium. The equilibrium constants of the forward and reverse reactions are related to each other. To see this, let us consider the following reaction at equilibrium. Reacts with oxygen and forms sulfur dioxide. The equilibrium constant for the forward reaction is given by Similarly, the equilibrium constant for the reverse reaction is given by equilibrium constant K2 for backward reaction. For reverse reaction, this is equation 2. Now equation 2 can also be written as 1 upon K2. That is new equation, equation 3. Now on comparing equation 1 and 3, we get the following relation. K1 is equal to 1 upon K2. This indicates that the equilibrium constants of the forward and the reverse reaction are reciprocal of each other. Ionization of water. We know that water is a very weak electrolyte and ionized according to the following equation. By applying law of mass action on this equation, here water is ionized to a small extent, hence it may be supposed to remain constant. My equation can be written as, here a new constant W will be used. Here Kw is a constant. It is known as ionic product of water. Therefore, the product of concentration of H plus ions and OH ions in water at a particular temperature is known as ionic product of water. Here, the value of Kw increases with the increase of temperature. That is, the concentration of H plus and OH minus ions increase with the increase in temperature. Now some values of Kw at various temperatures. At 0 degrees Celsius, the value of Kw is 0.11 into 10 raised to power minus 14. At 10 degrees Celsius, the value of Kw is 0.31 into 10 raised to power minus 14. At room temperature 25 degrees Celsius, the value of Kw is 1 into 10 raised to power minus 14. At 100 degrees Celsius, the value of Kw is 7.5 into 10 raised to power minus 14. Now relation between hydrogen ion concentration and nature of solution. For neutral solution, H3O plus ion concentration should be equal to 10 raised to power minus 7 moles per liter. For acidic solution, H3 plus H3O plus ion concentration should be greater than 10 to the power minus 7 m. And for basic solution, H3O plus ion concentration should be less than 10 to the power minus 7 m.